Okay. All right, so we're going to find the volume of the solid generated by revolving the region bounded by the graph. So y equals 2x squared, y equals 0, and x equals 2. Okay, so let's start with the figure here. Y equals 2x squared. What does that look like? Parabola. It's skinnier than normal, but okay. So there's y equals 2x squared. All right. Y equals 0. What's that? Which axis is that? X-axis. Good. All right. So there's y equals 0. And x equals 2. What's that? Vertical line, x equals 2. Okay? Do you see the area? Yes. Let's color it in. It's going to be this piece right here. Okay. I'm going to go ahead and copy and paste that to all my things just because it's just easier for me here. Let's see. What am I doing? Down here. Paste. And I got 2 more. Paste. That way I can manipulate those all differently. Okay? The area is all the same. All right, so we have this, and we are rotating at about the x-axis. Okay. Anytime we rotate, here's the x-axis. We are going to go this way. Okay, can you visualize what kind of figure you're going to make here? Okay, it's going to be kind of a bullish thing where we're going to have a gap. We have to be perpendicular to the x-axis, so if I go to there, we're going to be missing the yellow piece. So there you go, you get your R out and your R in. The little one is on the inside of the, that's the y-axis. Certainly is. Oh boy, let's y-axis is down here. Thank you. Wow. Okay, x-axis. All right. If I have to be perpendicular to my x-axis, all right, I'm covered. So what is this? The first one is a disk. Okay. Volume, disk. What's the formula for a disk? A disk is just a flat circle. I R squared, it's a cylinder. H being change in x, we hit the x-axis. All right. Okay, here we go. All right, so what's R? I. What is R? 2x squared minus 0. Very good. So we would probably just leave that out of there. Okay. And don't forget to square, because that's in this formula. Okay? All right, we're ready for an integral. What's 2x squared squared? 4x to the 4th. Okay? And now we got to get our boundaries. On x, we're going sideways here. X is sideways. I'm pretty sure it's 0 to 2. Let's stop at 2. Okay, so that's easy. All right, plug it in or do it by hand, either one. I'm just going to do it by hand. My 4 out. And my 5. I'm encroaching on my second one here. Let's see, what's that? 28 pi over 5. Did anybody do it though with the calculator? Yep. 45.6. Same thing. You could have any of those answers. 80.425. Okay. Any of those would be good. All right. So that's a disk. All right. Let's see what this is. The y-axis. I think we kind of snuck that in here a little bit. All right. Part B, y-axis. We're going to go perpendicular to the y-axis. So we're going to get to one piece. We're going to get to the other piece. If we have two pieces, that is clearly a washer. Bless you. Okay. Just like we're going to be memorizing, just like we had to memorize this formula. What's the washer formula? R out squared minus R in squared times pi. Okay? It's not the whole thing squared, it's each individual, because remember we took the big circles, pi squared minus the little circle, pi squared. Yes. Why would we now have a what? We do. We do. And that's your change in y. Okay. Yes. Okay. Biggest problem with washers, we get so involved in doing the radii that we forget the pi. That's a problem because of the circles. You gotta have a pi for circles. Okay. So let's see. Like we gave me the last R. Let's see. Ella, give me R out. 2. Okay. And we're in terms of y here. I just kind of put that in there. I didn't even like ask you all. You all know where that came from? Because what are we putting? What are we hitting right here? Waxes. So that's what we base that on. Sorry about that. Okay. All right. So 2 is definitely the space from here to here. Okay. Our in. Okay, remember we have to be in terms of y. So let's take care of that right away. Y equals 2x squared. How do we get that to solve for in terms of where, so we have y over here. What do we want to do first, Laura? Well, we got to get this R in. If you do it, you're going to say the red minus 0, but the red is in terms of x. We don't want in terms of x, we want in terms of y. So, what do we have to do this to get it in terms of y instead of in terms of x? Okay. And then square root, don't forget your positive and negative. Because which side are we talking about? The positive. Okay, so we don't really have to worry about the negative, because this piece is the positive. Equals x. Okay? All right. So what is our inside, Kimberly? Number minus little number. Square root of y over 2 minus 0, right, which is square root of y over 2. So here we go, plug them in. Okay, we're going to take r out, squared minus r in squared times change in y. Okay, you would have discovered as soon as you put that, like, oh, these have to match. Okay, you're ready for an integration. What's 2 squared? Okay. Claire, what's the square root of y over 2 squared? Y over 2. Okay, dy. All right. Now, remember y's are going up and down. 0 is the bottom. 2 is x. That is not 2 anymore. I'm guessing it's not 2. This point is the highest y. So if x equals 2, what's y? 8? I thought it was 8. Let's see. Here, x equals 2 equals y over 2. Square both sides? Yep. Y indeed is 8. Okay? So that's where that is. All right. Did we lose anybody? You could have also plugged it into just 2 squared times 2 is 8. You know, it's a lot easier. It just was handy right there to do it. But remember, y's go up and down, so you have to have the highest point up and down, not sideways anymore. That's x. We've already done the squaring. We're done with it. You have to use the x when you plug it into your calculator. Okay? What'd you get, Allie? Okay, so we're going to do it by hand. Don't wait for somebody else to do it. Come on, Allie. Not really good not to have checked.
Yeah.
What'd you get, Ella? You haven't done it either?
No, I'm doing it.
Okay, what'd you get? That's the problem. Volume should never be negative. Okay. Did you do by hand? Okay. Did you do it inside the ribbon?
Oh, I know what it is. It should be y over 4. I was thinking it was 2y. I did it like it was 2y and then divided by 3.
Okay.
16.
Right? 16 pi is correct, yes. 32 minus 64 over 4 is 16. There's your 16 pi. So you forgot this too? When you do the anti-derivative? Okay. And you just had y squared over 2. Okay. All right? Yes.
On the test, if we don't use our calculator, like, can we keep answers and like that long?
Of course. That's what I would expect you to. Okay, any other questions? All right, let's try the same thing, except now we're going to do about x equals 2. All right. X equals 2 is right here. We're going this way. All right, so I'm going to be perpendicular to it. All right. You've got to decide this quasher. This quasher. Which do you think, Brooke? This quasher. Disk. Why is that? There's no what? Okay. So I get that way when I just drew 1. What's the other reason? Because I just drew 1. I mean, I don't know how you draw another one unless you go way out, but that would be silly because then you're out of. Okay, what's the other reason? That I have a disc as opposed to a washer. Visually, what's the reason, Sarah?
Because when you rotate it around, x equals 2, there's nothing.
That's right. Very good. There's no space in between that rotating axis and where you have to draw your radius. Great. Okay, so pi r squared h. H this time is change in y again. Okay. Because if you can't continue on, we hit the y-axis. All right, we need an r. Okay, Jessica, why don't you give me the r in terms of y?
compress that 2x squared, radical 5.
Okay,
That minus 2.
okay. Which is bigger?
No, that minus 0.
Okay, you're gonna start here, right? Because that's bigger.
Mhm.
What is that? 2 minus the curve is, okay? It's the same way we did it. Well, this is disk, so, okay? The bigger number on your number line is to the right. So that was 2. The other one is y over 2, so we got to go that way. Okay? So, let's see. 2 minus radical y 2 squared, the whole thing, change in y. Okay. I'm just going to leave that alone because if I square it, I got to square it as binomial. I don't want to do that. I really want to spend the time. It's not as easy as squaring individually 2 and what we did before. Okay, we're in terms of y, so we should know our limits already. What are they, Alyssa? 0 to 8. Okay, plug it in your calculator. Or, if you don't have one, a little bit more challenging. Not anything you can't handle, but not one I be careful when you put that square in. Yeah. Well, you just add the pi to the end.
I forget.
Yep. Okay, that's 9. 0 to 8. I'm going to square the whole thing, so I need my extra set of parentheses, 2 minus square root of x over 2 square the whole thing. X. Okay, 5.3333333 is 16/3. If you want exact, it's this. If you're not going to get exact, then take it times pi right at the moment and do it to 3 decimals. It would be, geez, I already forgot it, 37755. Okay, either one of those are good. Okay. Be careful how you put that in. You got to make sure this quantity squared together. Remember the parentheses. Anybody not get that? Okay. All right, let's try the last one. Same figure. We're going about the line y equals a. You want to try it by yourself? Let's do it. Let's do it. Let's do it. I got the answer. I'm pretty sure when you're ready. And I don't care about exact or 3 decimals. Either one's okay. So, R out. 8 is the top, 0 is the bottom. So 8 minus 0. Okay. 8 is the top. We are in terms of x. So 2x squared is the bottom. Okay. So now we are ready. Volume, washer. Pi r out squared minus r in squared times h. H has already been determined to be changed in x. All right, r out squared is 8 minus r in. again, we're back to x is 0 to
Can you
2. Okay?
Can you explain why it's
Because the top number is the biggest number, that's 8. And then to get to the inside, I'm going to go to the curve, which is 2x squared. On the R out, we're on the top number, and we get to 0 every single time. Those are just 2, but remember that's your disk is sitting like that. So, all right. So I'm going to go ahead and put the answer here when you're ready. Either one of those. Well, if you're doing it by hand, you got to multiply this out. I don't think you're going to want to use substitution for integration if you don't have it. Okay? All right. That was kind of scary. Let's try another one. I did. Okay, find the solid form by revolving the region bounded by y equals radical x and y equals x squared about the x-axis. Okay, so go ahead and draw your figure. You should know how to draw both of those. Just have a big enough thing that you have some space between them here. If you have to plug it in, go ahead, but you should be able to do that without plugging in. Blue here. And red. Okay. If you're not color coding, clearly label, because then you don't have to worry about what's what when you have to go. Okay, so there's your shaded region. And we are revolving about the x-axis, which is right here, just so we don't forget. Okay, so what are we going to have? Washer or disk? Those are our two choices. What do you think? Washer. Very good. I'm going to be perpendicular to the x-axis. So I'm going to have a little gap there. This little guy is our inside because I've got to him first. He's on the inside. This bigger one is our out. Okay. Wow. Okay, so let's pick out what are we in terms of x or y? X, very good. We hit the x-axis. Both those in terms of x, which makes it easier. All right. What's my R inside K? Top, I the bottom. X squared minus 0, just to be anal about the whole top minus the bottom. Okay, very good. Okay. All right, Megan Carrico, what's my outside? Very good. Okay. Now, when we get over to the interval, we're not going to write the minus 0, but that's just to be clear. We take the top, because the top is our bigger number on our number line, minus the bottom. Blue is bigger, minus the bottom. Okay, we said it was a washer, so here we go. I'll let you go from there. Then I hit the button. All right. So we have pi r out squared minus r in squared times change in x. All right, r out is x squared. Don't forget to square. Sometimes if I take shortcuts, I do forget the square thing, and then square root of x. Square times pi.
yeah, so the way around. Because our outside is
Yes, it is. Yay, yay, yay. That's what, yeah, it's the place to be right now. Squares, squares, it's the place to be.
Oh,
Change in X, alright. 0 to 1, right? Because I got my intersection to be 1, 1. Anybody have any issues finding the intersection? Most of you did it by hand. Like I said, most of the time, I think it's just quick. Sometimes you are going to have to do that. Enter, 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 because it's going to be that long. It's not going to be pretty. So, there's your work here. There's your 0, and there's your 1. Okay. So then plug it in, and what do we get? If I'm plugging in, I would probably plug in x minus x to the 4th. Just then I deal with all that parentheses business, and get 3 pi over 10, or you could do 0.942 if you like decimals better. Okay. Very good. All right. We got time for another one. Any issues here? Okay, good. Go ahead, let's try one more. I'll get you. You can do it from the very beginning. So let me turn this back on. Here we go, ladies. I got it ready. We are doing what x-axis, right? Okay. So what is this? Washer. Okay. All right. What's R out? Cosine of x. I'll just do my 0 just to be kind of weird about it. And then our in is the little one, which is, that's the red one. Okay? All right, so, washer. I, R out squared minus R in squared. Change in what? X. Good. Because otherwise we had to do an inverse cosine out of it. All right. Hi. I'm going to go ahead and put in my cosine x squared, because that's how I'm going to put it in my calculator anyway. Okay. All right. So, integrate. All right, I know it's x, so it's 0 to whatever this is. Now, if you think about it, you could probably figure out that it's pi over 4, because that's where cosine and sine are the same. Okay? If you don't want to think about it, because that makes you crazy, then you go second, trace, intersect, get to the intersection. There's only one intersection in this window, so I could have just hit enter, enter, enter. There it is. Okay? Now, be careful about the rounding situation. If you weren't going to use pi over 4, you would use 0.785398816. Use as many as they give you, at least 5. Okay? Because what happens is you're going to round, and then we're all going to have different answers, and that's going to your teacher. Okay. So now you're ready to plug it in. Okay, did I lose anybody? The intersection thing, make sure you know how to do that, because there are going to be some intersections that are not pretty. All right, if you knew it was pi over 4, it's good. That's 9. 0 to, I'll do pi over 4 first, and then I'll put that value in here. Now, be careful. I got square cosine. The only way to do it is like that. Square it. Don't square the x. Square the cosine. Like I just did. I told you not to do it, and I did it. There's cosine of x squared. The calculator invents another parentheses that you don't like, but do that. All right, minus t. Minus. Okay, parentheses, sine of x, close the sine of x. Close the parentheses to square. The color thing is very weird about making sure you're all matchy on that. Okay, there's a half. So remember, that's pi over 2. Okay? Don't forget your pi. If you did math 9 with the 0, hold on. I'm just gonna go back up here and snip this so I don't have to mess with that whole thing. And then I'm gonna change my pi over 4 to 0.785, and you should see it'll be the same thing. So, okay. Delete 0.78. 539816. There you get the same thing. Okay. So just be careful about that intermediate rounding here. Okay.
Okay, so we're gonna-
It is 1/2 pi. Yes.